For 11.9, we're going to go ahead and calculate independence. So we're going to first use the example for number 7. We can talk about the probability that somebody uses a computer, and the probability that somebody uses a computer would be 600 over 1,000, which is 0.6. Taking a math class would be 700 over 1,000, which is 0.7. They are giving us in this example that they are independent. The fact that using a computer and taking a math class, because they are independent, 0.6 times 0.7 needs to equal the probability of a computer and taking math. And because of that, the probability of having a computer and taking math would be 0.42, which means we can start to fill out our table. And this one's going to be now 420, which was cell 1. And the rest of the items can go in accordingly. This one now becomes 280. This one is 400. This one is 300. This one is 120. And this last one here would be 280. Sorry, 180. Now we're going to use this table to calculate our next series of probabilities. So again, the probability of having a math class is going to be 0.7. The probability of being in a math class while also using a computer is going to be 420 over 600. This one calculates to also 0.7, and those two are equal, and they better be equal because it said in the beginning of the problem that they were independent. On the flip side of that, if you use a computer, you get 0.6. If you use a computer given you take a math class, this would be 420 over again 700, which is also 0.6, and those two are equal. Now using those ideas, we're going to look at number 12. And we're just going to do a couple of these on number 12 so you do understand what we're actually doing here. But this is talking about the Titanic, and we're talking about whether or not they're dependent based upon first class and passengers surviving. So you've got two options for it. You can say the probability that they survive. If they're equal, that means they're independent. If they're not equal, it means they're dependent. So this is going to be the probability that they survive given they're in first class. The other option for that would be the probability that they're in first class. And if they're dependent, then they would not equal each other. This would be the probability that they would be in first class given that they also survived. Now to calculate whether or not items are dependent, we're going to take what we just talked about. So I'm going to first calculate the probability of them of a survivor, and that probability of the survivor is going to be 442 over 1207, which is about 0.366. And we're going to show that this does not equal the probability that they survive given they were in first class. That probability is 197 over 319, which is about 0.618. That's how we can calculate, because they're not equal to, we can calculate that this probability is not equal to this probability, and because of that we can say they're dependent. On the flip side, you can do first class, the probability of first class, and that one is going to be 319 over 1207, which is about 0.264. And this one's going to not be equal to the probability of first class given that they survived. And that probability will end up being 197 over 442, and that is about 0.446. And we can prove that those two amounts are not equal, and we did that based upon our probabilities. So probability of first class does not equal the probability of first class given that they survive. To summarize what we're talking about here, these are your three ways to check for independent events. We've done this one multiple times now prior to this, and in lesson 9 we did these two. But now these are your three ways to clarify if something is independent or not. And remember, if those two are false, then it's dependent. If it's just this, they're not independent.